Okay, so let's discuss a question from thermodynamics. You have a thermodynamic cycle which is represented in a PV diagram. So let's draw a PV diagram by a circle of 10 centimeter dia. So this is a circle, okay, and so 10 centimeter dia. So the dia is 10 centimeter, okay, okay. So net work done during the cycle. Now work done during the cycle during in cycle is area enclosed, okay, by the area enclosed by the cycle. So this is a circle and circle area is pi by 4 d square. Now remember that when we plot the graph, what is given is 1 centimeter on x-axis is kg per second, and whereas 1 centimeter on y-axis is kilojoules per kg. So basically this is given in mass flow rate, and this is given in kilojoules per kg. But the area which is given is in centimeter square, because diameter is in centimeter. So if you multiply the diameter 10 centimeter square, so what you get is basically pi by 4. The area of the circle is pi by 4 d square, and it's pi by 4 10 square. So this value, when I calculate pi by 4 into 100, so this value comes out to be 78.54 centimeter square. Now remember this centimeter square, 1 centimeter square should represent joules, right? Okay, and it is given that 1 centimeter, basically they have given it, instead of giving in volume and pressure, they have given in mass flow rate and work done plus mass flow rate. That's okay, because 1 centimeter should represent joule. So when you multiply this, because ultimately PV diagram area should be in joule, so 1 centimeter is 3.16 kg per second into the other value is 115.2 kilojoules per kg. So if you multiply these two, so yeah, 1152. So if you multiply these two, the value which you get here is, after multiplication, because that will represent 1 centimeter square, so this value is 364 150 into 2, so 364.032 kilojoules per second, and that is nothing but kilowatts. So 364.032, okay, 32 kilowatts. So that you have to multiply here. Okay, so 78.54, because 1 centimeter represents 364 kilowatts. So how much 78.54 will represent? You have to just multiply. So this value comes out to be 28590.13 roughly kilowatts. So answer is 28590.13. So it is just the area in a cycle is, what you need to know is the work done in a cycle is area under the curve, and that is pi by 4 d square, and you have multiplied that, and now 1 centimeter they have given a different scale of representing 1 centimeter. So if you multiply those two units, like 1 centimeter on the mass scale and 1 centimeter on the work done per mass scale, multiply that 1 centimeter represents 364.0, so that is basically 364 kilowatts. So now how much 78.54 will represent? So you have to just multiply and get the answer. So 28590 kilowatts. Thank you.